We continue the probabilities using table data, and in this case we are using a two-way table. We've talked about two ways before. Why is it a two-way? Because we can read it two ways. You can talk about RH, positive or negative, this way, or you can talk about the type of blood this way, right? So two-way table. Number 3, a blood bank catalogs the types of blood given by donors during the last 5 days. One donor is selected at random. Let's take a look at the data. Remember, you want to look at the table, make sure you understand. In this case, I already went through initially and I said, okay, this is a two-way table. I can read data to the left. I can read data up and down. So I feel like I have a pretty good understanding of the table. Another thing that I also want to do with two-way tables and any table in general is if I'm going to need the totals, I want to make sure totals are there. So this is the total of type O, type A, type B. We have totals this way, so I see my totals are there, and then an overall total. If these aren't there, then you need to take the time to fill them out before you go and you answer the questions. So I feel that I'm ready. It says leave the probabilities in fraction form. Do not turn into a decimal. How many donors have type O blood? Type O blood is 184. Let's find the probability a donor has type O blood. So what is going to be the probability of the event is going to be the frequency over the sum of frequencies. And we have 184. And how many donors total were in this catalog? 409. Part B, how many donors are Rh negative? So we're looking at Rh negative, so I'm looking this way, my Rh negative values, and we have 65 Rh negative. Let's find the probability a donor is Rh negative. So we have the probability of the event is equal to frequency over the sum of frequencies. We have 65 over, and it says a donor, right? And how many donors do we have? We have 409. Part C. Out of the donors that have type A blood, okay, so I'm just looking at type A blood. So I'm looking here, type A. How many are Rh positive? Ooh, this one gave us more details and was even more specific. So these are Rh positive. That got really dark. I'll correct that in a second. So we have 139 of those are type A and Rh positive. So out of those that have type A blood, what is the probability that a donor is Rh positive? This one is completely different than A and B, because look at A and B, it just said a donor, a donor. What does C say? Out of those that have a type A blood. So all I'm looking at when I'm looking at my probability of my event and the frequency over the sum of frequency, I can only look at the sum of frequencies at the type A blood, which is 164. Who is Rh positive here? 139 of them. Let's go ahead and see if we can simplify. 139 divided by 164. So I always check 2, 3, 5. Doesn't mean you can't divide by anything else, guys. You gotta be careful, but that's what helps me the most. So let's check, are they both even? No. Do they both end in 0 or 5? No. How about if I add 1 plus 3 is 4, 4 plus 9 is 13. 13 is not divisible by 3, therefore I believe this is simplified. Last one. Out of the donors that are Rh negative, how many have type O blood? Let's look at type O blood right here, right? 28. So out of those that are Rh negative, so that's already giving me a clue on what I need to look for. All I have is the Rh negative people, so it's 65. What is the probability that a donor has type O blood? The event is type O, which is 28. Our probability is 28 over 65. Let's go ahead and simplify. Let's look for even numbers. No, they're not both even. Do they both end in 0 or 5? No. And 3. We're going to do 2 plus 8 is 10. Is 10 divisible by 3? No. Therefore, this is as simplified as it is. So be careful with a donor versus a specific thing. You are going to try number 4. I hope the first thing you notice is that your totals are empty. Then everything else should be very similar.